Hello everyone. In this video, we will discuss three concepts: algorithm, flowchart, and pseudocode. So I am A. Lakshman Rao, Department of IT, Aditya Engineering College. So we see these three topics in this video, and later we will discuss other topics. So what is an algorithm, flowchart, and pseudocode? So first we will theoretically define all these, and later we will see some examples for each of these. So first coming to algorithm. So algorithm is nothing but some set of steps to complete a particular task or instructions to solve a given problem. So algorithm can be represented in an English like text, and you write all the steps in algorithm in a set of instructions. Nothing but step 1, step 2, step 3 like that. So for example, consider an algorithm. So every algorithm contains some steps, number of steps. So step 1, step 2, 3, 4, 5. So we'll see some examples for algorithms. So real life example. First, we start with a real life example, and later we will see some more examples which are related to programming. So consider, how do you make a Maggie? So all of you know how to make Maggie. Of course, even though we don't know, some content is there on that packet, how to make it. So we will try to write an algorithm for making a Maggie. So first we pour some water onto the bowl, and later heat the pan. And what is the next step? You see each of these as in step. Some pour masala packet into that pan, and later add noodles and stir well and cook. And after some time, after 5 to 10 minutes, so you serve. So these are 6 steps. So this is an algorithm for making a Maggie. So each of these is nothing but a step. So this is step 1, and similarly step 2, 3, 4, 5, 6. So this is one algorithm. Similarly, in real life, there are number of algorithms. Algorithm for making a coffee, algorithm for making a phone call to a friend. So you can write. So when I ask you write an algorithm, and some of you may write that algorithm in 5 steps, and some of you may write in 4 steps. For example, see, you may combine this step 2 and 3 in a single step. Somebody. So there is no rule how many steps we need to write. So you can write algorithm in your own way. But what important is, finally you must make Maggie, nothing other than that. Okay, so that is important. So what exactly an algorithm? It is a step-by-step procedure for solving a problem. Okay, simply it is step-by-step procedure for solving a problem. So depending on the problem, we write an algorithm. If it can be making a Maggie or making a tea or making a phone call, whatever it may be, depending on the problem, the algorithm is written. So example, consider an example. Algorithm for finding the square root of a given number. So you need to take one number and find its square root value and display its value like that. How to write an algorithm? So for every algorithm, generally we write the first step as start and the last step as either stop or end. So start and stop, we write first and last steps. That is a good way to write an algorithm. So step 1, start. Step 2, read a number x. For example, as I told you, square root of a given number. So I'm not given any number like 2, 3, like that. So any given number. That's why I generally call that number as x, for example. So first you need to read that number x, and later find the square root of your x. So it can be any number. In the next step is find the square root, and later so display your square root value. So that is an output. So after calculating the square root value, you display it or print it. And step 5 is stop. So this is an algorithm for finding the square root of a given number. Of course, you may not write these in 5 steps. You may write in 4 steps. But what you need to do for calculating a square root of a given number? So you need one number. After that, you calculate square root and you display as the output. Okay, these 3 are the basic steps. You may combine those 3 as 2. It is not a problem. But the procedure must be written as a step-by-step way. That is an algorithm. So come consider another example. Algorithm for checking whether the given number is positive or negative. So before writing algorithm, you must know what is a positive number, what is a negative number. So what is a positive number? If any number greater than or equal to 0, that is a positive. Less than 0, negative. So you need to know that. So to write an algorithm, what is an important thing here? You need to know what is the procedure for that problem. If you don't know the procedure for making a Maggie, how can you write an algorithm for preparing Maggie? So we must know the procedure for completing that problem. Then only you can write an algorithm. For example, now how to write algorithm for checking whether the given number is positive or negative. Start, read a number x, for example. Once again, I have not given any number, given number. So that's why you may consider it as an x. If x is greater than or equal to 0, print x is a positive. So a number x is greater than or equal to 0, that is a positive number. If x is less than 0, it is a negative number. And stop or end. You can write either end or stop. So reading the number, and after you, for writing these steps and 3 and 4, you must know what is the logic behind positive and negative. If you don't know what is positive number, what is negative number, it is difficult us to write these steps. And next, consider one more example. Algorithm to add two numbers entered by the user. That means sum of two numbers. You need to take two numbers as input and later display the sum value. So same procedure. Start. Second step, read two numbers here. So instead of one number, we need two numbers. I call the numbers as A and B. You may give some X, any name. For example, I consider the two numbers. One is A and one is B. So first I read two numbers, add two numbers and store result in another variable C. For example, so the sum value is stored in C. So simply it is nothing but C is equal to A plus B in step 3. Later print that C and stop. So here you need two numbers because in the algorithm you asked that add two numbers entered by the user. So that's why we need to take two inputs here. So these are some algorithms. So now every algorithm must have some characteristics. So algorithm is good when it is good if it is satisfied by some characteristics. So there are general characteristics, lot of characteristics are there, but important characteristics we will try to see. First, input. So your algorithm has 0 or more inputs. So without any input, there is no need to write an algorithm. So definitely every algorithm must have some input. Similarly, output. So algorithm may produce one or more outputs. So generally, if you consider an output, what is output for a previous example? Sum of two numbers. So if square root of a number. So for previous examples, that is the output. Similarly, finiteness. That means your algorithm started and some process is done. After that, it must be finished. So algorithm cannot enter into infinite loop. For example, so write an algorithm for making Maggi meals. You put all these in the stove, and if you keep on the stove, what happened? Nothing happened. So at finite amount of time, you must stop. So that means finiteness. So algorithm must always terminate after some finite number of steps. That means you don't write an algorithm in a infinite way. So never ended process is not an algorithm. You must start and stop. So in between start and stop, you will write. So that's why we need to write start and stop. Algorithm must have that stop point also. So these three are the important characteristics. Of course, we may also explain some more characteristics, but I add some two characteristics, including this definiteness. What does it mean? Every algorithm in your algorithm must, every instruction in your algorithm must be clear. That means you write an instruction, and if that instruction is not possible to implement, then there is no meaning to write that instruction. So your instruction must be clear. Every step must be clear. And similarly, effectiveness means your algorithm must be effective. That means it must be practically possible to implement. So you have write some algorithm, but if that algorithm is not possible to implement, there is no need to use that algorithm. So that's why your algorithm must be effective and it can be done exactly in a finite length of time. What you have written, that can be done exactly, implemented exactly in the similar way. So these are the 5 characteristics of algorithm: input, output, finiteness, definiteness, and effectiveness. Okay, next, after completion of algorithm, we will see flowchart. What is a flowchart? So what is an algorithm? Simply, it is a procedure to describe a problem. So for every problem, we describe it as a step-by-step process. That is nothing but an algorithm. Now, flowchart. So flowchart is a graphical representation of an algorithm. So your algorithm is a English-like steps, but you represent that in a diagrammatic way. That is nothing but a flowchart. So a diagrammatic representation of way to solve the given problem is nothing but flowchart. So whatever you shown in the stepwise process, that can be converted into diagrammatic notation, then that is nothing but a flowchart. But how to construct this diagram? We need some symbols. So there are flowchart symbols. There are a lot of symbols, but we will see some basic symbols. Okay. So to draw this flowchart, we need to know some flowchart symbols. For example, oval or closed rectangle. This is used for start and stop. As I told you, every algorithm, first step is start or begin, and last step is either stop or end. You can write anyway. And the start, stop, begin, or end, these can be represented using the symbol oval or closed rectangle. This is called a terminal symbol. Next one is parallelogram. So this symbol is used for input-output operations. For example, you are reading a number and displaying the output. So you are reading a number x and displaying square root of x. So that number x reading a number is input, and displaying the square root of x is an output. So for all of this input-output, we use this parallelogram symbol. Similarly, rectangle. So rectangle is nothing but any calculations or operations in our program. So it is called a process symbol. So that means, for example, addition of two numbers. So you use an operation addition. So addition of A, B. A is first number, B is second number, A plus B. That is one operation. So that type of operations can be represented with a rectangle. Similarly, diamond symbol. This is a decision symbol. What does it mean? As I told you, whether the given number is a positive or negative. So here there is a decision. Definitely your number must be either positive or negative. So you will check the condition. If that is greater than or equal to 0, it can be yes or no. That is the decision. If the number greater than or equal to 0 is yes, what does it mean? That is a positive number. No means that is a negative number. So for the decision making, we use a symbol diamond. Similarly, connector. So it is used to connect different parts of a flowchart. For example, your flowchart is a big enough to cross first page. So 2 pages of flowchart. So you put a circle in the first part or end of the first page, you put a circle, and beginning of the second page, you put a circle. So what does it mean? There is a connection, there is a continuation from the first page to second page. Like that, to connect different parts, not only in 2 pages, in single pages also, you can do like this. So to connect different parts of an flowchart, we use a circle symbol. So what are these symbols? Up to now, we discussed 5 symbols, and this last one is a flow symbol. That means, as we discussed, step 1, step 2, step 3. So we need to show the arrow symbol, step 1 to 2. Similarly, after step 2, next step is step 3. So like this. So to show that flow, we use arrow symbol. And these are the basic symbol. So start and end, this is the symbol. Oval symbol or closed rectangle. Arrow symbol is nothing but flow direction. Similarly, this parallelogram is for input output. And a rectangle represents a process symbol, which is used for calculations. And a decision symbol is nothing but a diamond symbol, yes or no decision. So now we will try to see one example flowchart. So flowchart for finding area of a circle of radius r. Okay. So first we will try to see an algorithm, and later it is easy to draw a flowchart. If we are having an algorithm in our hand, it is very easy to draw a flowchart. So first try to write an algorithm for this one. So what is algorithm for finding area of a circle of radius r? So as you already know, we need a variable r, radius r. First you need radius r. So read that. After that, calculate area and display it. So start. So this is the start symbol. So closed rectangle symbol, or you can also use a oval symbol. Similarly, the second step is read the radius r of the circle. So what symbol we need to use here? So reading a radius r, reading means nothing but input. So what is the symbol we use it for input? Parallelogram. So read radius r. Of course, you may write here, enter a radius r, read a radius r. You can write in English like sentence, like an algorithm, you can write anything here. But it must represent that it is input. In the similar way, you must use parallelogram. And what is step 3? Yes, area calculation. After reading radius, for example, area is equal to pi into r into r. Okay, of course, that pi value may be 3.14, whatever it may be. So this is an operation or some calculation here involved. So we use rectangle symbol. So area is equal to 3.14 into r. And we use rectangle because this is a operation or calculation. Similarly, printing area. Printing or displaying means, okay, after calculation of area, we need to display it. So that is nothing but output. So once again, we use parallelogram symbol. So for input and output, parallelogram. And finally, and what is the symbol? Either oval or closed rectangle. So it is very easy to draw a flow chart if you are having an algorithm in your hand. So from the algorithm, it is easy to draw the flow chart. You just need to know what are the symbols used to draw the flow chart. Consider one more example. Flow chart to read two numbers and find their sum. We already completed an algorithm for this example. So what is algorithm? A start, same thing. Read the first number n1. So once again, input. So parallelogram. Similarly, read the second number and 2. Once again, I put another parallelogram. But you can also write in a single step. You combine just step 2 and 3 and write read two numbers, some x comma y or n1 comma n2. And you write here read n1 comma n2. There is no problem. You can write in a single step or 2 steps. Not a problem. Similarly, step 4, add these two numbers n1 and n2. So what is the symbol we need to use? Yes, rectangle. Sum is equal to n1 plus n2. And finally, print your sum is an output. So use parallelogram. Okay, so this is one more example for flowchart. Finally, stop or end. So next, consider one more example. So algorithm and flowchart to print larger of two numbers. So here, how to check whether the number is large or not? For example, two numbers are there, x and y. How do you know that which number is big? We need to use greater than operator. So if x greater than y, x is big. Or if y greater than x, y is big. So here some decision is involved. That means if x greater than y, that is a condition. So definitely the answer of that if x greater than y is either true or false. That means yes or no. If x greater than y is yes, then something happened. If it is no, something happened. So here we need to use a symbol called diamond. That is nothing but decision symbol. But before that, we need to read two numbers. That procedure is same. So start, read two numbers a and b. For example, if a greater than b, then a is big. Otherwise, b is big, and end. See how simple to write an algorithm. But to show this yes or no, here otherwise means no. And then if a greater than b, then means yes. So true and false. So for this, we need to use a diamond symbol. See the algorithm. So start. Second step is nothing but reading two numbers. That is parallelogram. And see now I added a diamond. What is in diamond? Yes, the condition. If a greater than b, that is a decision symbol. So definitely the condition can be either true or false. If it is true, a is big, so print a. If it is false, b is big, so print b. So you need to put these two, that is both true and false. Of course, there are three paths actually, path 1, path 2, path 3. you can use any of these two, true, false. But see, there are no three outputs for if A greater than B. So if A greater than B, only two options, yes or no. So you must represent these S as true and no as false. You can write yes or no also, not a problem. Okay, so you write true here, false here. That is also not a problem. So left it empty. But you must write two paths. What happened if true? What happened if false? So in this case, it is true. I want to print A as big. Otherwise false. I want to print B as big. And both connected to end. See here, one important thing you need to observe. Here, what is the path it follows? So like this. So either this print A or print B, in these two, only one statement is executed. So not two statements execute at the same time. That means all the boxes in our algorithm may not be implemented. For example, if A value is big and B value is small, then this path is not executed. Similarly, if B is big, then this path is not executed. Okay. So this is an algorithm and flowchart for printing largest of the two numbers. Consider one more example. This is somewhat tricky. Flowchart to increment a x value, and initially the value of x is 0 by 1 until it reaches 0. So I had given a variable x, and initially the value of x is also given 0. And what is your task here? Increment its value by 1. So x is 0, you increment it, then it becomes 1. And if you increment again, it becomes 2. If you increment again, that becomes 2. 3, 4, 5, 6, like that. Until it reaches 10. That means you start with 0 plus 1, plus 1, plus 1, plus 1. You do this task up to it reaches 10. So here, if you want to write as a step-by-step way, how you write? First x is equal to 0. Next, add 1. Next, add 1. Add 1. So if I am adding 1, 1, 1, because I had given increment x value by 1. So I said, if there is 0, if you add 10, then automatically it becomes 10. But what is the task? Increment the value by 1 only. But that means at a time you add 1 only. If it is 0, you add 1. That becomes 1. Once again, if you add 1, that becomes 2. If you add 1, that becomes 3. So you need to write 10 steps, 0 to 10. Similarly, if I will put here 100 instead of 0, then you write like 100 steps. So until it reaches 100, I had given. So step 1, step 2, step 3, up to 100 steps. That is not a good practice. So in programming languages, this type of tasks are called repetitive tasks. So here, what is my task? Incrementing x by 1. And I want to repeat the task 10 times. Okay, the task is same. What is the task? Add 1 to the previous value. But this adding 1 is repeated n number of times. That can be 10 times or 100 times. So how can you write a flowchart, or how can you write an algorithm for this? See, it is somewhat tricky, but not so much difficult. See here, start. So I used this symbol, start symbol, well symbol, and initially x is given. I use a rectangle. Why? So x is equal to 0 is an operation actually. So you are assigning a value 0 to x. So assignment operation is done. So I use a rectangle. After that, see how I used this diamond symbol. So x less than 10. So I checked this condition. If x is less than 10, initially what is the value of x? 0. So initially 0 is less than 10. Yes. So if x equal to x plus 1. So I added 1. So initially x is 0. So 0 less than 10 is true. So now I write x equal to x plus 1. That means 0 becomes 1. X value becomes 1. Later you observe this flow symbol. So I put back to here. That is the power of these arrow symbols. That means after becoming x as 1, now once again I came here. That means now x less than 10 means now the x value is 1. 1 less than 10? Yes. So now it becomes 2 because I incremented. Once again came back. 2 less than 10? Yes. Now it becomes 3. 3 less than 10? Yes. Now it becomes 4. 4 less than 10? Yes. Becomes 5. 5 less than 10? Yes. Becomes 6. 6 less than 10? Yes. It becomes 7. 7 less than 10. 8. 8 less than 10. 9. 9 less than 10. But if it is 10, 10 less than 10? No. So end. So it is incremented until it reaches 10. Whenever it becomes 10, 10 less than 10 is false. So it comes to end. See the power of this backflow. So I use this arrow symbol and backflow. So it is repeated n number of times. If you give 100 also, you just write the condition x less than 100. See how it is useful to use these backward direction arrow symbols. So instead of writing 10 times, 20 times or 20 steps, use this diamond symbol and arrow flow symbol in a backward direction. Okay, so that is called as repetition in your program. You repeat this in a loop. So you repeat this task n number of times. So of course, you can also write an algorithm, assign x with 0. If x less than 10 is true, go to step 4. What is that? Increment. And after increment, come back again, checking the condition. So similarly, if x less than 10, come to the end. Okay. So this is the way to write an algorithm and flowchart for this problem. Of course, there is a tool called Raptor for drawing these flowcharts. Tool. The purpose of this tool is you can draw the flowcharts using this tool. So I will show you the Raptor. So this is the site where we can download the Raptor tool. Of course, there is no need of link. Simply you type in Google page also, you will get. For example, I open Google page. So Raptor download. You type Raptor download and press enter. So you will get this, open this first page, the same page. So here, so there is a download latest version tab. You just click it and download it. I will show you one or two flowcharts, how to draw the flowcharts. So I already installed in my laptop. So if you open Raptor, it shows like this. So start and end is already there. It uses vowel symbols. For example, if you want to insert input symbol, just click it using mouse and you just drag that rectangle symbol or parallelogram symbol or whatever may the symbol you want, just move it to your window. Okay, I will open again. Okay. So see here now, I added an input symbol. Okay. So if you want to write something to input symbol, just right click it. So click it first and later right click. So for example, I want to write read number X. For example, you can write anything, but within double quotes I have that. And variable name I am using X. You write like this. See here what it shows. Read number X, get X. So it will automatically add get X. Similarly, after reading, I want to do some operation. For example, X equal to X plus 1. So simply we just use this rectangle, because what is the purpose of rectangle? Yes, rectangle is for operation. I want to do some operation here. So just click it and drag it. So after clicking, it shows in a red color. Then you need to drag it. Okay, your mouse must be in a good condition. Otherwise, it is difficult to drag it. Okay, so the rectangle. So rectangle, what you need to do operation. So generally the format is like this. Set means I want to set X as X plus 1. Here there is no need to use double quotes or etc. So above you need to write on the left hand side, below you need to write on the right hand side. I want to add an instruction X equal to X plus 1. For example, see X equal to X plus 1. So in this way, you can use all these symbols in Raptor. So there is a help is also there. You just go to it. If you want to put a diamond symbol, you just add it. So yes or no paths already given. So similarly, if you want to write a condition, you can write it. Similarly, if you want to delete a particular symbol, just right click and cut. For example, I want to add condition some x greater than 0. Or x greater than or equal to 0. So x greater than or equal to 0. Of course, there is no need of x equal to x plus 1, but to show rectangle, I used this. So x greater than or equal to 0, then you put here some output. See, output symbol is separately given. Of course, in Raptor, actually, some output symbol is given. But generally, if you are writing a flowchart, we just use the same symbol. What is that? Parallelogram. But here, the two different symbols are given. Yes, you can write here. It is an yes, you write print output. How to write print output? So here x is a positive number. So x is positive like this. You can write in double quotes. So generally it asks save this. So save with any number. For example, flowchart 1 F1. And x is positive like this. Okay, this is the Raptor. So you can do some operations and first you need to write an algorithm and flowchart. First you will try to take one problem, and for that problem, it is better to draw this in Raptor. Okay, so I am closing this. So you can try different examples, not so much difficult. And next, coming to pseudocode. So of course, generally we use the algorithm or pseudocode in a similar way, but actually there is a lot of difference. What is pseudocode? Okay, algorithm and flowchart completed. Now pseudocode. So pseudocode is also a set of instructions that are similar to programming language instructions. Mimic means nothing but duplicate. So these are not a programming language instructions, but similar to programming language instructions. That means algorithm is a complete English-like text, but it is not a program. So if you consider a pseudocode, it is somewhat similar to programming language. That means algorithm to pseudocode to program. That is a good way actually. See, it is one of the tools used to write a preliminary plan before developing your program. That means before writing program, you write pseudocode. Before writing pseudocode, you write algorithm. So it is a general way. That means your algorithm or pseudocode don't show what is the programming language you are using. You write an algorithm. So that algorithm can be used for any programming language. So similarly, pseudocode is also same way. So you write a pseudocode, and that pseudocode can be converted to a C program or C++ program or Java program. Okay. So the name only suggests pseudocode. Pseudocode means not a original code. It is a just a sample type of the code. Before the code, this is a preliminary step. That means it cannot be executed on a real computer. So it is also like English text. Okay. So somewhat similar to an algorithm, but in algorithm we write a pure English notation. In pseudocode, we can also use mathematical notation. Okay. So some examples. Pseudocode to add two numbers. For example, I had write begin and end. There is no rule to write begin and end. You can write start and there is no need to write begin end or start and also. You just write as usual in a English-like text. So first set sum is equal to 0. So that means I want to add two numbers into sum. And later read number 1, number 2. I call num1, num2. Set sum is equal to num1 plus num2. Print sum. What is the difference between the pseudocode and algorithm? Yes, pseudocode is most widely used notation before writing the program. But nowadays, actually, we are not using the pseudocode or algorithm. Generally, we write a program, but it is in a more mathematical way. When you consider algorithm, you write take sum as 0, enter, read two numbers, like that. You can write if you want to convert it into algorithm. If you want to write an algorithm for add two numbers, we use more English-like text. But in pseudocode, we use a mathematical notation that is similar to program. Similarly, consider one more example. Pseudocode to find area of rectangle. So I use the terminology here, read width and length. For example, after that set area is equal to width into length, print area. So what is a pseudocode finally? It is the informal way of writing a program. That means not a program. So before program, you may write it. It is not exactly a computer program. It represents the algorithm of the programming in natural language and mathematical notations. That means we use English-like text and mathematical notation. That means when compared to algorithm, it involves more mathematical notations, which is nearer to programming. Okay. So this is about pseudocode. So we discussed algorithm, flowchart, and pseudocode. In the next video, we will discuss some more topics. Thank you.